Function translations 1.1. Just a quick review of the definition transformation. It alters the equation and location, shape, or orientation of a graph. Transformations will alter all functions in the same way regardless of the type of function we are working with. So here are 8 different types of functions we're going to come across in this unit. A linear function, and that has a basic starting equation of just y. That's not the equation of this line, but we start with a basic equation of y equals x. A quadratic equation, we start with a basic equation of y equals x squared and then alter that equation. An absolute takes the shape of a v or sometimes a w depending on the type of absolute value function you're taking, but a basic is going to be, in this case, the absolute value of x, or it could be technically any absolute value function of anything. If it's a quadratic, then there would be an x squared in there. A cubic function is the next step up from a quadratic, so it starts from a basic function of simply y equals x cubed. Quartic, again, is the next step up from cubic, which takes a basic function of y equals to the 4th and then can be altered from there. A radical function, again, takes a basic form of y equals square root of x, and then that again is altered or transformed. A rational function, again, this can vary depending on the type of function we're starting with, but the base is something like 1 over x or 1 over x squared. And we get into more detail of rational functions later in the year. And sinusoidal, this is the start of trig. So the basic function, we really see any trig functions in this unit, but just to be aware, sine of x or cos of x. So moving on, let's see what we can remember from quadratics from grade 11. If the function y equals x squared has been transformed to y equals ax minus p all squared plus q, how do a, p, and q affect the graph? So thinking back to math 20, if you can remember a shape of the graph, so depending on the value of a, that made the graph wider or narrower. And how, so whether it's a positive or negative, it opened up or down. Our p-value, if you can remember, actually moved the graph left or right. Left or right, which we call a horizontal translation. And our q value, if you can recall, moves the graph up or down. So essentially, when we learned about these values in grade 11, we are starting to transform graphs. Even though we didn't necessarily talk about the transformation all the time, that essentially is what is on this basic function y equals x squared. So today we are just going to focus on translations of all types of functions. So a translation is a type of transformation that can move the graph of a function. A translation occurs when the location of the graph changes, but not its shape or orientation. So as an investigation, let's say y equals some function, whatever that function is, doesn't matter. Therefore, y would equal f of x. So when we see f of x just represents some random, I don't know what that function is specifically, but it's representing a function. Let's investigate the effects of a, h, and k have on that function f of x. So when we talk about transformations, we might see the following notations. We might see a notation on the function as this, y minus k equals f of x, Or if we moved k to the other side, you might see a notation of y equals f of x plus k. You're going to see these both notations, so you do need to be aware that this is technically the same as this. Okay? And the other notation we're going to look at is y equals f of x minus h. Okay? So remembering f is just a random function. We don't know what function it's referring to. And then we're going to say due to any specific function. So investigating the k value. Okay, so let's suppose we started with a function of f of x equals absolute value of x. Well, if we're going to graph that original function as a dotted line, and we're going to use a table of values to see the effects of what happens when we take that function f of x and we add 2 to it, and we're going to graph that as a solid line. And I've already done that here for you. So I've randomly picked 6 values, substituted these values into my absolute value function of absolute value of x, and this would be my output value. So I took these points and plotted them on the graph, and it came up with this original function y equals f of x, which is my dotted line. Now I want to see the effects of, well, what happens if I add 2 to this function? Well, 2, if I substitute in these same x values into this function and add 2 to them, all of these y values should be 2 more than the original, which is what happened. And so essentially what happens is this entire original function y equals f of x has moved up 2 units. Okay? Okay? So when we start to transform things, it's really important to have a good sense of what these basic functions look like before we start. It really is an aid for us when we transform functions. So moving on, let's do something, again, really similar, but we're going to graph this without a table of values now. So we're just going to go off of kind of remembering what our basic quadratic function looks like. Say f of x is now equal to x squared, which is our basic quadratic function. And we're going to draw this as a dotted line again, and then we're going to translate this by taking y equals f of x minus 2, and we're going to graph that as a solid line, and then we're going to write the equation of that. What would the new equation look like? So, if you can recall a basic quadratic function, there's no translations have occurred here, should look like the following dotted line, right? Our vertex is going to be at 0, 0. For 1 unit of x, we want to square that unit of x. So 1 squared would give us 1, 2 squared would give us 4, 3 squared would give us 9, and so on. And same thing with our negative values. So that's how I kind of figured out exactly the shape of that graph and what it should look like. Now we physically want to subtract 2 basically from all of our y values. If you look at this function, f of x is really representing our y value. Subtract 2 from every y value on our function. So what is going to happen to our function? Our entire function is going to move down 2 units. And so what is our new equation going to look like? Well, our new equation is going to look like y equals x squared is what our original function started as, and then we're subtracting 2 from all of those values. So y equals x squared minus 2. All right, technically what does our k value do? Our k value moves the graph up or down. All right, so let's investigate what h does now. So again, let's start with this basic absolute value function. Before absolute value of x, using a table of values, again, I've chosen points here, substituted that into our function to get our output value, and plotted my original dotted graph here, which is y equals f of x, or y equals absolute value of x. So similarly, we are now going to see the effects of x plus 2 does. So what this means is we want to add 2 to our original function and then take the absolute value of that. Okay? All right, and this is, sorry, I'm just seeing. Y value of 1, not a negative 1, so let's just fix that. Okay, so let's see what happens here. So if I start with a negative 3 and I add 2 to that negative 3, I get a negative 1. Negative 1, now I'm going to take the absolute value of that entire function. The absolute value of negative 1 would be positive 1. So when x is negative 3, my y value should be positive 1, which is right there. If I take a negative 2 and I add 2 to it, I will get 0. The absolute value of 0 is 0. So that's this point. Negative 1 plus 2 would be 1. Absolute value of 1 is 1, which is this point. And so on. So I've plotted each of these points for x, put it into my function, and then taken the absolute value of that function to get my output values. And so we can see from this graph, this is my new transform graph, the graph physically moved left 2 units. Okay. So recognize this is an x plus 2, but the graph actually moved to the left. So can we predict what's going to happen here? So again, instead of an absolute value function, we're going to start with our quadratic again, seeing our effects without a table of values. So an x squared without a table of values, again, we're going to get that same dotted graph as we did before, which is y equals f of x. And f of x minus 2. So now taking 2 from my x values and then squaring them. Okay. So, for example, this vertex point, if I subtract 2 from that, 0 minus 2 is negative 2. Negative 2 squared would be 4. So when x is 0, y should be 4. Okay? At this point here, when x is 1, 1 minus 2 is negative 1 squared would give me 1, which is this point here. When x is 2, 2 minus 2 would give me 0, and then I'm going to square that function, which would give me 0, and so on. So as we can see, this graph is moves right. And so what would my equation look like? So again, anything that's in brackets, this means we want to apply this to my x value first before we're squaring something. So my new equation would be I need to apply this to my x first, and then after that I'm going to square my function. And so that was what our new equation is going to look like. Okay, so in summary, okay, remember this is the function we are starting with. Okay, this is very key, or it might look like this. Okay, where your k value is on the left-hand side of the equation. I always, before we talk about transformations, I always encourage you to always solve for y first and then talk about transformations. So when we talk about a transformation, if your k value is positive in this form, I'm talking this form right now, k means the graph is going to moves up k units. A negative k means the graph moves down k units, whatever that k value is. A little bit trickier. Lots of students get confused. They see an x minus h and think this is a negative h value, but in fact it's a positive h value. If I substitute a positive number in here, it's going to stay an x minus 4, let's say. And so technically that positive number. So a positive h, even though in the equation it looks like it's a negative, moves the graph right h units. And a negative h moves left h units. Okay?